Um,
This one you have to use the squeeze theorem.
oh, oh yeah. Okay. Squeeze theorem.
Yeah, think about what
Wait,
sine x behaves like.
sine x,
Mhm.
it's just like this, like goes up and down, up and down, up and down.
Yeah. What is sine x always bounded by?
One and negative one.
Yeah. So sine x is always bounded by -1 and 1, right? And we were just
Uh,
taking we were just dividing everything by x, right?
yeah.
So what is the limit of this?
Um,
X approaching.
0,
Yeah, 0. This is also.
0.
Yeah. So the thing in between 0 must be always 0. So that's the squeeze theorem. So the limit of this is 0,
Huh.
right?
I don't
Okay.
know if I don't know if I've ever done that.
All right. And the next one is continuity. Do you remember the condition, the three conditions of continuity?
Um, isn't it if it's continuous?
Yeah. Like you could draw a function without lifting your pen, right? But in terms of limit.
Oh, isn't that the x equals c
Mm-hmm.
limit
X
from
this.
yeah. And then limit of f of x as x approaches c from the left and right are both the same.
Yes, right. So that's the
Yeah.
definition of limit. So this limit has to exist,
Yeah.
right? Limit
And
exists.
then the limit and the limit of f of x as x approaches c is equal to f of c.
Yes, they both have to equal to each other, right?
Yeah.
Like this. So limit exists, the value exists, and they must match, right? That this is
Uh-huh.
condition of fx being continuous is continuous at x equals c. Okay, so you'll see like the graph looks like this. There's a hole here, and another value is different. Like look at it here. Is this continuous?
Is that continuous? No.
Why?
Because f of c is different than the limit as x approaches c.
Right. So
Because it's defined at 2, but the limit is approaching -2.
yeah, yeah. So FC exists, right? FC
Yeah.
exists, but limit exists, but they don't match each other, right? So this
Hmm.
is called removable discontinuity. Right again. So if f is continuous
Uh-huh.
in this interval a and b, and let's say there is one value in between, let's say m, in between f of b and f
Yeah.
of b, f of a and f of b, then there exists c such
Yeah.
that f of c is equal to m. Does it make sense? This graph.
Yeah.
Okay. And I'll pick m, like let's say there's m in between f of a and f of b. So let's say this
Hmm.
this is m, right?
Yeah.
And the limit value, the IVT says there is c in between a and b, such that f of m, f of c is equal to m. So there should be c, like here, right? In this case, oh,
Yeah.
not here, but in this case, here, right? There must at least
Uh-huh.
be value, right? This is what intermediate value theorem says. Okay,
Yeah.
so the question would look like it's like mostly a proving question, like show that they give you the function like this has
Yeah.
root between 2 and 3. This is a
Uh-huh.
question.
Okay. So then prove that.
So we have to find c, the root that makes f of c equal to 0.
Uh-huh.
Makes sense? So we have to find c.
Okay. So would it be like a root 5?
Mm, no, because if you put root 5, uh,
Because that would make the top 0.
right, it will be root 5, but you have to prove that.
You have to, Okay, how would I? I'm not sure how to prove that.
So root 5 is this one, m, right? We found it, right? We're going
Yeah,
backward. We know that m, but you just have to show that root 5 is in between f of a and f of b. You have to get f of 2, right? F of 2 is
yeah.
negative 1 over 3. And then f of 3 is 4 over 4, so 1, right? So we know that there is a number m
Uh,
in between f of 2 and f of 3. We know f of 2 is negative 1 over 3, and then f of 3 is 1, right? So we know that
mhm.
0 is in between here. So there should be some,
Oh,
yeah, some value that must be in between this interval because it's between negative 1 over 3 and 1, right?
oh, okay.
Yeah.
All right, that makes sense. That makes sense.
Okay. So this is like the typical IDP question.
The limit definition.
Mm-hmm.
Wait, H is on the bottom, right? H is by itself on the bottom.
Mm-hmm. Yes.
Oh, wait. Is it f of h plus x or
Uh-huh.
h plus x
Uh-huh.
minus f of x?
Yes.
Okay.
Um, you're gaining an instantaneous slope, right?
Uh-huh.
So when you like back in algebra or pre-calc, you always have to have 2 points in order to get slope. So let's say this
Uh-huh.
is like A and FA, and this is B and FB. And
Yeah.
normally you would get slope with the 2 points. The slope of this is rise over run. So it's F of B minus F of A over,
B minus a.
right? But we're getting instantaneous slope. So we want that 2 points to be close as possible, right? As if they are almost right next to each other like this. So we
Uh-huh.
want to say this margin, this interval H, and we want to
Yeah.
minimize, we want to send that H to 0
Uh-huh.
to get the instantaneous slope. So instead of B, I'll just write the neighboring, the point right next to A plus H. And then obviously this will be A plus F of A plus H, right? So
Yeah.
first you would just get the slope as we normally do. Then it will be F of A plus H minus F of A plus H minus A, right? I'm just following the same definition.
Uh-huh.
Does it make sense? Then
Yeah.
I'm going to send H0.
Mm-hmm.
And A cancels out, right? A and minus A.
Yeah.
Yeah, this is how we get this formula.
Oh.
Next one thing would be MBT. Remember anything about MBT?
Yeah, let's go MBT. MBT is f prime of whatever is equal to f of b minus f of a over b minus a.
Yes. Okay. Do you remember the condition of A and there? What are the relation?
Uh, C is in the middle.
Yeah, C has to be greater than A and then less than B. So
Yeah.
the form of definition is the function f is continuous,
Uh-huh.
and if x in the interval of A and B and has derivative like f
Hmm.
of x in AB, then this condition it satisfies this condition.
Okay.
Right. Okay. I shouldn't say shouldn't write it like as derivative x in this interval. Okay, so this one is also, let's say I have a function like this and I have two intervals A and B, and then I would have f of A and then f of B. We first get,
Uh-huh.
so this is the mean, right? This is the mean value of A and B. So this
Yeah.
and this, if you're to visualize, this is the mean. This is the mean of A and B.
Uh,
And is always C in between A and B that will be that has the same slope, same instantaneous slope as the mean value. So this is parallel, right? Same slope.
Mhm.
And there is always C in between A and B here that has the same slope, same instantaneous slope as the mean value of A and B. Like,
Mhm.
oh my gosh, this is C. I'll draw a table like this. Uh, F say prime, F prime prime, right? So,
Uh,
and if F is increasing, does F prime greater than zero or equal to zero or less?
F prime is positive.
Yes, it's positive, right? Like this.
Yeah.
And then what if it's decreasing?
F prime would be negative.
Yes, less than zero, right? Okay. And let's compare when F is at C. And when does F have local minimum?
Uh, Minimum
Yeah.
is when f of x is 0, but f double prime is positive.
Yes. So if you have a critical point at here,
Uh-huh.
this is the critical point. The left side should be
The left side would be decreasing and right side would
uh-huh.
be increasing.
Yes. And then the F double prime will be positive. Yes. Right?
Yeah,
And if it's local max, it
the
would,
opposite.
yeah, the opposite, right? If you have a critical value C, then it should be increasing to decreasing, and then the F prime double prime would be less than zero. What if you got the critical value, but you don't see any change?
Uh, then it's not well, it's not a local min or max.
Yes, it's not local minimum max.
Yeah.
It's like the situation where it kind of looked like this.
Points of inflection is when f double prime is equal to 0.
Yes, equal to zero. And this determines whether it's concave up or concave down, right?
Yeah.
And so we have two cases. One, f prime of C is a minimum, and it's going decreasing to increasing. In that
F
case, then this is point of inflection, right? And then which side would be positive and negative?
if it's going from decreasing to increasing.
Like this, right? Okay. And then
So that would be like it would be yeah, it should be going like that, right?
yeah, yeah. And then the other way, it's opposite. If f prime is max, then we're just going f double prime is going positive to negative.